Okay, welcome to this webinar. Thank you for being here. Um, there you go. Okay, so my name is Matteo. I'm a product manager at Move Solutions. Um, the topic of today's webinar is going to be our latest release in terms of products, the environmental sensor. Um, just one thing, I'm going to answer at the end of this webinar any question that you might have. So just type it into the question section or in the chat, and I answer that at the end. In case I didn't get the chance to go through all the questions, you get an answer. We'll just email you with the answer to your question. Also, we'll send you the recording of this webinar at the end. Okay. So first off, just give you an introduction on solutions for whoever is new. We design and manufacture structural health monitoring sensors, wireless structural monitoring wireless sensors. Let me just give you a quick overview on our system. We have dynamic and static devices from a high level of analysis. We have for example, a dynamic displacement sensor for the detection of dynamic displacement waveforms. Still in the dynamic world, we have an accelerometer that can detect acceleration waveforms for modal analysis and all those algorithms. We also have a vibrometer for construction monitoring for PPV, monitoring, the frequencies and all of that construction side of monitoring. We have a tiltmeter. At this point, I'm talking about static monitoring. We have a tiltmeter for inclination detection. And then just there you go. The environmental sensor, which is what I'm going to present today. And then last but not least, the single channel node to connect. It's basically a data logger to connect a wide variety of analog probes from, for 20 milliamperes down to the vibrating wires. This was just a quick overview on our sensors portfolio. We are also a software company. We have an IoT platform. It's called MyMove. We just released it last year. We've been growing on this side a lot in the past 12 months. MyMove is a platform that allows you to manage your infrastructure, to explore the data. So the data is collected by a wide range of different devices, and you can see that data on MyMove. And then we also have the analytics. So we have a bunch of tools that will help you understand those trends and, analyze that data. We're gonna see MyMove later a little bit because I'm going to show you the new environmental sensor that we just released into MyMove so that you can also look at the data on an actual, IoT platform. Okay, so let me start with this new release. First off, let me say that as all of our sensors, we're talking about a wireless LoRa-based device. So LoRa means, it's a communication protocol that allows us to reach long distances with a low power consumption. The sensor is battery powered, but so it doesn't need an external power supply, but you can connect an external power supply in case you wanted to extend, the battery life. And the sensor can measure basically a wide variety of different parameters related to noise, air, and wind. So now we're gonna go down into details and see exactly what this sensor does. From a high level perspective, let me say first that the sensor is structured has been designed in 3 different agents. So we identified 3 different agents. An agent is basically a cluster of channels that performs certain types of you know, analysis and can detect certain parameters. Different agents work in completely different ways and can be completely independent with respect to one another. So this device has 3 different agents. One is the wind agent that contains 2 channel, wind direction and wind speed. The other one is the air agent that has 2 channels, the rain and the air quality channel. We're going to see them in the details later. And then we have the noise agent that only performs noise-related, like a noise-related monitoring. So the reason why we wanted them to be separate is because that allows us to set them on different parameters. For example, the sample rate on each one of these agents can be different. And other setting parameters like like the averaging windows, like whether or not you put them in low power mode. So you can work these 3 agents independently with respect to one another. So what you're having is basically 3 different sensors in one, and these 3 agents can communicate with the servers in a completely independent way. So it's 3 sensors in one. Data collection is synchronized within the agent. So that's also interesting, is that, within an agent, everything is synchronized, but then between different agents, you can have the 2 agents working completely different ways. Something else that is interesting about this device is that you don't have to get the full package with all of those channels. We're talking about 5 channels total. So it's a modular approach that allows you to have some external probes that you can decide whether or not you want them. And of course that will affect the price as well. It will scale depending on what you need to be in there. As you can see, these are the external probes. We have a rain gauge, we have a wind speed sensor and a wind direction sensor. We're going to see them in details. So let's start with the first agent, wind. Again, it's 2 channels, wind direction, wind speed. We just saw them in the previous slide. So what this agent can do, it can measure, of course, wind speed and wind direction, but in a couple of different ways. It can collect instantaneous data. It can collect average data, so it can basically sample for a certain amount of time and then provide like an average acquisition. And then over a certain time range, it can also provide the maximum value. So we're talking about wind gust monitoring, and I'm talking about wind speed. And then alongside that, there is always information on the wind direction, so that you and those are synchronized, so that you can correlate the data. There's also the possibility to activate a trigger functionality. So you can set a threshold. If that wind speed is surpassed, you get an acquisition. And in terms of sample rate, you can set the sensor to work on a wide range of sample rates from 2 minutes to down to 24 hours. The 2 channels will share that sample rate. So at that specific sample rate, what you will get is an acquisition from both wind direction and wind speed at the exact same time, so they can correlate the data. The second agent is the air. This agent contains a lot of different parameters. On one hand, there is the particulate matter monitoring. We have the PM1. We have the capability to detect PM1, PM2.5, PM4, and PM10. Those are detected always at the same time. You don't have to choose which one you want. They're always provided, all of them. Alongside that, the sensor can also collect temperature, pressure, and humidity. So those are parameters that are, it's really interesting to correlate with the particulate matter trends. So that's one channel within air agent. The other channel is the rain. It's an independent channel in there. And that was the tipping bucket that we saw a couple of slides before, a couple of slides ago. So what that channel does, it can collect the total amount of rain that has fallen over a certain period of time. So it can monitor that. It can monitor that parameter over time, and then it can also work on trigger. So you can set a threshold, and you can get an acquisition when a certain amount of rain has fallen over a certain amount of time that you can specify. So that's a trigger mode. And then we have the noise channel. Well, the noise agent, within the noise agent, all of it is, the noise channel. What that agent can provide is all of those regulated parameters according to the IEC class 1. So we designed it after, we designed it to be able to collect those parameters that are specified in the IEC 61672 class 1, and then the British standard as well, as you can see up there. So more specifically, what the sensor can do, it can provide the equivalent value of sound level on a selectable time window. It can provide the maximum sound level and the peak sound level. And then it can provide those statistical parameters, L10, L50, L90, both on an A and C frequency weighting, and then fast, slow time weighting. So, these are all parameters that pretty much all the regulations around the world require. So we designed it to make sure that we can provide all of those specific parameters that are necessary in noise monitoring. This sensor can monitor up to 5 weeks of continuous data just on batteries, but again, you can connect it to an external power supply, to a 12 volt, to have a longer monitor, continuous monitor. Now, a couple of details on now that we know what the sensor can measure, what the sensor can detect in terms of parameters. Now we can see the different working modes that we can have, and a couple of details on how the sensor actually works. Well, first off, on some of the channels, there's a possibility to have either a low power or an always on working mode. The low power, the mechanism behind low power, basically that channel, if it is in low power, it will wake up whenever the sample rate requires it to wake up. It will provide an acquisition, and then it will go back to sleep. While doing that, it will provide those instant values that are detected when it wakes up, and we will be able to save a lot of the battery life. So we'll be able to increase the battery life by a lot. So I would say, like, that's the suggestion whenever you want to prioritize having the longest possible battery life. On the other hand, there is the always on mode that is able to unlock some different parameters. So basically the channel in this case is constantly on and is constantly monitoring at high frequency. So what it can also provide, alongside, of course, the instant values, but it can also provide some average values and some maximum values within a time range that you can select. Also, since at that point in always on, the sensor is constantly monitoring, you can also set a threshold, and you can also activate on some of the channels a trigger mode to get an acquisition whenever that threshold is surpassed. Another detail on how the sensor works, again, well, actually we've talked about this, but again, the two type of acquisitions that the sensor can provide are programmed and triggered. The programmed acquisition, you just set a separate, and then the sensor would provide either only instant values if it's low power mode, or if it's an always on, also average values and maximum values. But at that specified sample rate, something else that you can do on some of the channels, you can specify an evaluation window. So what's going to happen is that when the sensor is calculating the average values at that specific sample rate that you set, but it's going to look at the previous averaging window, at the previous evaluation window, to allow like certain regulations require, in order to be compliant with the regulation, require, for example, to average over 12 hours. You know, with like a moving window that moves every hour by hour. So you know, this working mode would allow you to have, I would say, like a moving window type of. So for example, every hour you look at the previous 12 hours, and then you can set like a threshold and be compliant with your regulation, for example, not on noise monitoring or on particulate matter monitoring. And then the trigger mode is the other type of acquisition. Again, we've talked about that. Set a threshold, and the threshold is surpassed, you get the acquisition. Additional functionalities, the sensor can store data on its flash memory, and it can also work when the sensor is offline. So you can activate a specific working mode that, in case the gateway, because of course you need a gateway to communicate, you know, to be in between the sensor and the servers. So in case the gateway went offline, what's going to happen is that the sensor will keep detecting, you know, and providing acquisitions. It will store those acquisitions on its flash memory. It's an extremely interesting feature because it gives you time to go and fix the problem that you have in your installation without actually losing the data, and you can still have continuous data. Now a little bit on the applications for this device. Construction, definitely I would say the most common. I'm thinking of particulate matter, I'm thinking of noise, you know, but also wind speed and wind direction, especially in relationship with the particulate matter monitoring. Bridges, here I'm thinking of more of like a weather station type of application, is also but also noise monitoring and particulate matter. And then railways, again, noise monitoring, wind speed and wind direction, and so on. But there's a lot more application, just a couple of examples. Well, what I'm going to do now, I'm going to stop sharing my screen, and I'm going to show you some real data on our platform. There we go. So this is my move, and this is all the data. Let me see. There you go. So air quality. You have, as you can see, the instant values, average values, maximum values. In this case, the 4 different PM parameters are overlapped on the same graph. You can see them with also pressure and humidity, and you have the RAN channel where you can see here you have the cumulative values that you're looking at right now. So you're seeing in every single time slot, you're seeing the total amount of rain that has fallen. Both on the cadence time, but also on the evaluation window. So you can set, for example, 1 hour cadence, and here you get every hour, you get the amount of rain that fell in the previous hour, and that will be on this graph over here. But you can also set an evaluation window of 12 hours with the cadence of 1 hour. So what's going to happen is that every hour, the sensor is going to provide the total amount of rain that fell in the previous 12 hours. So that's the moving window type of monitoring that I was talking about. So you can compare these two graphs and see on different time ranges how the data is different. You can see a temperature trend, maximum and minimum, and you can see how the temperature changes in between those, like in between that range. With the sound, again, you have an A-weighted sound level overlap with the equivalent sea level. C-weighted, sorry, sound level. You have the maximum sound levels, and then you have the peak values for sound pressure, and then you have those statistical noise levels. A-weighted over here and C-weighted over here. I don't know how many of you are noise monitoring experts, but these are parameters that pretty much all of the regulations require. Here you have the wind channel, which right now is just showing overlap, the wind speed and wind direction on the same graph. What we're doing right now, since I would say it's coming soon, we are putting together a windrows that would be right here. So you'll be able to see the typical windrows with all the sectors for the wind direction and the wind speed categories, where you can select maybe like a B4 wind velocity scale and maybe a 16 wind direction sector, and then you can build that windrows that kind of statistically shows you the percentage of of the time that the wind was blowing from a certain direction and in a specific wind speed category. Something else that you can do is change the aggregation criteria. There's a lot of data on our databases. When the data is retrieved, you kind of have to pick and choose what to show. So not all of the points are retrieved to allow like an easy understanding of the trend that otherwise would have thousands and thousands of points. So what you can do, you can select within the time slot, the aggregation time slot, you can select if you want to see the minimum values, the maximum values, or just the first point within the time slot. And then you can change the time range over here. And as you can see, this time slot change. Oh, I selected the time range as no data. And as you can see, the time slot changes in size. You can also export the data. And yeah, I mean, I would say that's pretty much it. Show a presentation again. Okay, well, that's pretty much it on my side. Sorry, guys, I started from the beginning. Yeah, now I'm open to questions. Let's see. The webinar, the webinar will be sent to you. So we'll send you a recording. So don't worry about that, which you have the recording. Yeah, if you have any questions. Um, okay, well, thank you. Let me see. Maybe we do have oh, there we go. We would get a spec sheet of the ticket bucket, please. Of course, yeah, for sure, we'll send it to you. Andrew's asking, do you have sensor for underground use and how has been signal transferred from low to ground? Yeah, that's you know, with wireless sensor, it's always you know, like kind of like a tough point whenever you have to go underground. Um, I would say that, you know, whenever there is whenever it somehow flows to the outside, you know, the LoRa technology can be pretty surprising. So we have been able to work also in closed environments like that. It depends on the case. Okay, well, thank you. Again, we'll send you the recording and see you at the next webinar.